Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim Shahmi bin Muhammad Yusof. My matrix number is DE210091. Okay, for today we will present our group project for BEV 30303, which is power generation, transmission and distribution subject. Okay, first our project topic is PV of grid system. My group consists of 4 members, which is the first members is me myself, Muhammad Hazim Shahmi bin Muhammad Yusof. The second members is Muhammad Iqmal bin Cik Mat Salwi. The third members is Muhammad Iqmal Fitri bin Farizal, and the fourth member is Nik Hairul Hazril bin Nik Fazil. We are from group 5 and section 4. Okay, so I will start with the introduction. Okay, electrical generation is the process of producing electric by using generators. In a generator, the conductors of the coil cutting the flux, which results in the production of electricity. Okay, nowadays, there are technology developed called solar energy, which is used to harness the power of the sun. Over the past few centuries, solar energy has been extensively utilized in a variety of conventional technologies. The usage of solar energy is strongly promoted because of the unpredictable weather conditions caused by the weather patterns, the incidence of increasing pollution, and the absence of reliable source of electricity. The solar panel is the equipment used to produce electrical energy from the sun. Photons strike solar cells and dislodge electrons from their atoms. The positive and negative sides of the cell can be connected with wires to create an electrical circuit. And lastly, electricity is produced when electrons go across a circuit. A solar panel is made up of several cells, while a solar array is made up of many panels. Solar panels are composed of several smaller components known as photovoltaic cells, which convert solar energy into electricity.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqmal Fitri bin Farizal. My matrix number is DE21010. This is a Pendeka Musta single story house. This is the problem statement of this project. We as a consultant engineer, we should prepare a proposal for an off-grid renewable system. The off-grid renewable system that has been used in this project is photovoltaic, which is a solar system. Then we designed of the prototype of the renewable generation model. As you can see here, there was a house model which is a solar panel on the top of that house. That solar panel will reach the sunlight. Then calculate the costing of the total of the load of the house. This project costing is around 30,000. Then after 7 years, Pendeka Musta will have a return investment around 4,000. The total load of this house should be calculated because we know how much spec module that solar module that we can use, then the spec of size solar panel. That's all. Thank you.
Okay, so next is the manual calculation. This is the load calculation. Okay, as you can see, the table consists of components used in the house, the quantity of the components, the estimated power, total connected loads, maximum demand, and design current. Okay, so to find the total connected loads, the formula used is estimated power times quantity. To find the maximum demand, we use the total connected loads divided by power factor, which is 0.85. Next is the design current, which is the formula is maximum demand divided by 240 volt. Okay, next is the total connected loads. To find the total connected loads, we just have to total the connected loads for each equipment, and we can see that the total connected loads for all the equipment is 6,440 watt. Okay, for maximum demand, The total maximum demand is we just total all the maximum demand that we get for each component, and the total maximum demand we get is 7576.47 watt. And lastly, for the design current, the formula is the same, which is we total all the design current for each equipment, and for that we get 31.57 ampere. Okay, the first table is the total energy consumption. As you can see, we already calculate the total energy use in a day, which is we take into consideration the usage, which is hours per day, and we will get the total energy use. Okay, the next table is the electricity bill for 1 month. Okay, the electricity bill for 1 month we get from the TNB calculator at Google, and we get that based on the total energy use in a day, we will get the total energy use in a month, and based on the total energy use in 1 month, we will get that the current bill is 64 ringgit 60 cents for 1 month. Okay, so the total energy consumption in 1 day is we just total the energy consumption for all the equipment, and we get the 9.32 kilowatt per hour. Okay, for total energy consumption in 1 month, we just calculate the total energy consumption in 1 day that we already get, which is the 9.32 kilowatt per hour times 30, which is the 30 days for 1 month, and we will get 279.6 kilowatt per hour. Okay, next is the total energy consumption in 1 year. Okay, the formula used is the total energy consumption in 1 month, which is the 279.6 kilowatt. We just times with 12 months, which is a year, and we will get the 3355.2 kilowatt.
Assalamualaikum. My name is Muhammad Iqmal bin Jamat Salmi. My number matrix is DE210098. So for my part, I will present about simulation part, which is in this project we will use a PVC 7.3 software in order to do a simulation for PV system. So these are the simulation of the software. First of all, to use this software, we need to give a coordinate of the place of Pendekar Musta house. So in this simulation, we just need to click new site and choose the material, the coordinate of the placement. So in this, we will use a kampung atap here. Then for PV panel position, we need to click at the orientation. So these are the position of the PV panel at the rooftop. Each angle, this panel tilt and azimuth is an angle of the PV panel. So for this plane tilt, if we use the number about 12, let's say 12, they will be affected at the global on collector panel. So if we put at the 12 plane tilt, it will have about 1794 kilowatt hour per meter square. But if we put about 6 degree, it will be 1802 kilowatt hour per meter square. And also for the azimuth, if we put at the 90 degree, and the placement of the PV panel will be at the east. So it also will affect at the global on collector panel. So in this case, I just use north angle, which is 0, and we get 1802 kilowatt hour per meter square. So next is a user needs. So in this unit, it shows all the requirements or all of the electrical appliances that have been installed at the Pernikahan Musta house. So as you can see here, he used about 5 units of LED lamps and about 1 PC and TV, about usage about 200 watt, and domestic appliance about 3, and so on. And this will be give a total for daily energy that he used for one day, which is about 9,344 watt hour per day. And for monthly energy, he will use about 2,280.3 kilowatt hour per month. And this is how they distributed for the appliance that he used for this electrical appliance. So let's continue for the system part, which is we need to declare the system of the PV system that will be used in the Pernikahan Musta house. So for this type, it will cover about 3 things, which is battery bank, PV panel, and also the converter. So for the first is a battery bank, which is battery storage. So in this project, we will use a brand from Panasonic with the type of lithium ion. With the requirement of the battery is a battery pack voltage about 48 volt, global capacity 988 H, store energy 39.7 kWh, with the total store energy during the battery life about 28,646 kWh, and it requires about 70 units of it. Then for the PV array, PV panel, we will use a 440 WP35 volt with the mono 440 watt twin 144 half cell. It requires about 6 units of it. Then for the converter, we will use a MPPT 1000 watt, 48 volt, 60 amp, 31 amp with the universal converter with MPPT converter. Then we need to run the simulation in order to get the result from this PV system. So these are the result of it. So we just need to click a report, then we good to go.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nik Hairul Hazrin bin Fazil, number metric DE20045. I will continue for our presentation with environmental impact. So we have 2 environmental impact, which is conventional power generation and chosen renewable generation model. So for the first one is conventional power generation, I choose fossil fuels. The impact is first coal power. Sulfur and nitrogen oxide contribute to smoke and acid rain. While this helps reduce local contamination, it does not help at all with global issues. For the second is fossil gas power. This power plant emit nitrogen oxide, but this is less dangerous than NOx from gas appliance in houses. It can be improved by cogeneration and geothermal. The last one is fuel oil and diesel. Dirty oil is burned in power plant in few oil producing countries. Diesel is often used in backup generators, which can cause air pollution. So that is for the conventional power generation. And for the second one is chosen renewable generation model, and I choose solar. Why? Because first, water use. Solar PV cells do not use water for generating electricity. Water use depends on the plant design, plant location, and the type of cooling system. The second reason is hazardous materials. The PV cell manufacturing process includes a number of hazardous materials, most of which are used to clean and purify the semiconductor surface. The last impact is based on land use. Depending on their location, larger utility-scale solar facilities can raise concern about land degradation and habitat loss. So that is all from our group. Thanks for watching. Bye.